nothing has been concretely found about how the brain works that in theory could not be mimicked by a Turing machine, a computer, a classical computer. So as far as we know, everything that the brain does is computable.
It's not necessarily bad, it's just outside of human control. Now, the thing that's going to be tricky here is that it's going to be very tempting to use AI as a weapon. It will be used as a weapon. The danger is going to be more humans using it against each other, I think, most likely.
Look, if an oracle told me far from the future that GPT-10 turned out to be a true AGI somehow, with maybe just some very small new ideas, I would be like, okay, I can believe that. Not what I would have expected sitting here and would have said a new big idea, but I can believe that.
What's ironic about all these AI safety people is they are going to build the exact thing they fear. We need to have one model that we control and align. This is the only way you end up paperclipped. There's no way you end up paperclipped if everybody has an AI.
Hello world. We are at a tipping point. Something on the horizon has the potential to forever alter the way we live. We are on the cusp of creating a new form of life, a new consciousness that could lead us to unimaginably advanced and bright future we always dreamed of, or bring us crashing down and leaving us as nothing but a cold memory of a once striving civilization that created its own end. The thinking machines are not something new for the imagination of human mind. From giant bronze figure of Telos in Greek mythology, who would throw huge boulders at the ships of invaders and make detours daily around the island to guard its makers, to the magic mirror of the evil witch, who you can ask anything you want to know to dominate the kingdom. Frankenstein, Tin Man, Whole 9000, Skynet, we just keep dreaming a form of intelligence that we build to hold our intellectual hand and help us along the way. Now we have AI that we can have simple conversations with, and we still strive for more. So how did we get from there to here? Aristotle and Plato pondered the possibility of creating machines that could think and reason. But it wasn't until the 20th century that AI emerged as a legitimate scientific field. This breakthrough didn't happen because one genius suddenly opened the doors of synthetic consciousness one day. It is the culmination of many brilliant ideas from many smart people, stacked like bricks, building on one another, slowly and methodically. In 1947, Alan Turing published a groundbreaking paper titled Computing Machinery and Intelligence, proposing a test for machine intelligence that is still used today called the Turing test. It is a test of a machine's ability to exhibit intelligent behavior similar of a human. It is basically like this. A person sits in a room and talks to two other people, one of whom is a machine. The person does not know which one is the machine. If the person still cannot tell the difference after an hour of conversation, then the machine have passed the test. In today's world, it's like having a chat on the internet with a person you don't know, then finding out that it's actually a chatbot. Alan Turing had a tragic end that we still mourn today, but his legacy survived, and the fuse he lit kept on burning. So much so that in 1956, Dartmouth College in Hanover, New Hampshire, held up a workshop. The workshop was organized by John McCarthy, Marvin Minsky, Nathaniel Rochester, and Claude Shannon, and brought together 10 leading researchers in mathematics, computer science, and information theory. The goal of the workshop was to explore the possibility of creating machines that could think and reason like humans. It is widely considered to be a founding event of the field of AI. Over the course of the workshop, the participants discussed a wide range of topics related to AI, including the nature of intelligence, how to create intelligent machines, and the potential benefits and risks of AI. The term artificial intelligence used at this workshop for the first time. The Dartmouth Workshop had a profound impact on the development of AI. It helped to solidify AI as a legitimate field of research, and it inspired a new generation of researchers to pursue work in the field of AI. 1 year later, Alan Newell, Herbert Simon, and Cliff Shaw created the Logic Theorist and the General Problem Solver. The Logic Theorist was the first program to prove mathematical theorems automatically. It was able to prove 38 of the first 52 theorems in the second chapter of Principia Mathematica, a landmark work in mathematical logic. General Problem Solver, affectionately called GPS, was a more general problem-solving program. It was able to solve a variety of problems, including puzzles, games, and logic problems. GPS used a technique called means-end analysis to solve problems, which means it was breaking down a problem into smaller sub-problems, then finding solutions to the sub-problems. Both these programs laid the foundation of the field of artificial intelligence as we know it. Then came the infamous Lighthill Report. Lighthill Report, also known as Artificial Intelligence, a General Survey, is a report published in 1973 by James Lighthill, a British mathematician and aeronautical engineer. The report was commissioned by the Science Research Council, SRC, to evaluate the state of AI research in UK. The Lighthill Report was highly critical of AI research in UK at the time. Lighthill argued that AI researchers were making unrealistic promises and that their work was not producing any meaningful results.
Concern tonight, however, is with the overselling of the longer-term future of computers. The scientific community has a heavy responsibility to put forward its carefully considered view of the facts to avoid the public being seriously misled.
He also criticized the SRC for funding basic research in AI, arguing that it was a waste of money. Lighthill Report had a significant impact on AI research in UK. The SRC reduced funding for AI research and many AI researchers left the UK to find work in other countries. The report also led to a loss of confidence in AI research, and the field went into a decline for several years. However, the Lighthill Report also had some positive effects. It forced AI researchers to focus on more realistic goals and to develop more rigorous methods for evaluating their work. It also led to a renewed interest in the foundations of AI and to the development of new AI technologies, such as expert systems and machine learning. Today, the Lighthill Report is still a controversial document. Some people argue that it was a valuable critic of AI research at the time, while others argue that it was a harmful document that set back AI research in the UK by several years. 80s and 90s have witnessed the birth of neural networks. It was a new way of teaching machines how to think. The shift from symbolic AI to statistical AI made them more scalable and robust. And the birth of web search engines and speech recognition systems made them more accessible to the general public. There wasn't any sudden leap. The technology was slowly maturing, with every little small step taken by many people around the world. But those small steps were crucial to make the machines understand and solve problems better and faster each day. Finally, this gradual progression started a fundamental shift in the way we look at thinking machines with IBM's Deep Blue. Deep Blue was a chess-playing computer developed by IBM in the 1990s. It was the first computer to defeat a reigning world chess champion, Garry Kasparov. Deep Blue was a supercomputer with over 2,000 processors. It was a combination of brute force search and heuristics to evaluate different chess positions. It was able to think millions of moves per second, which gave it a significant advantage over human players. Deep Blue's victory over Kasparov was a major milestone in the field of AI. It showed that computers could now compete with the best human chess players in the world and even beat them. There was never going to be a human mind again who is better at chess than the machines we created. This sparked a renewed interest in AI research, and it led to the development of new AI techniques that are now used in a wide variety of applications today. Then we entered the new millennium, and everything started to roll like a giant snowball down to a mountain. In the year 2000, the first version of the open-source natural language processing library NLTK is released. In 2002, Sony released Abo, a robot dog that can learn and adapt to its environment. 2003, the DARPA Grand Challenge, a competition for self-driving cars, is held for the first time. 2004, DARPA begins funding its Robotics Challenge program, which aims to develop robots that can perform complex tasks in disaster zone. 2006, we met Siri. 2008, Google releases TensorFlow, an open-source machine learning library. 2010, the first version of the open-source deep learning library PyTorch is released. 2011, Google begins using deep learning to improve the accuracy of its search results. 2012, IBM launches Watson, which would be two-person at the TV show Jeopardy! 2015, Google releases DeepMind, a research lab that uses deep learning to develop new AI capabilities. Then came 2016. It was the year AI proved that it's not just good at straight math problems or chess. It proved us that it can almost think. It was the year Alphago beat Lee Sedol at Go. I want to explain the game of Go here a little. Go is an ancient abstract strategy board game for two players. The goal is to surround more territory than the opponent. It originated in China more than 4,500 years ago. It is a deceptively simple game to learn, but it is incredibly difficult to master. The rules are straightforward, but the strategic depth of the game is immense. There are more possible positions in Go than there are atoms in the universe, making it impossible for a computer to brute force the game. One other thing that makes Go so difficult is that it is a game of incomplete information. Players cannot see all the stones on the board at once, and they must constantly make decisions based on incomplete information. This requires a deep understanding of the game and, more importantly, a high level of intuition. That's why when they announced that Alphago, a computer program, is going to have a match with the worldwide grandmaster Lee Sedol, nobody gave Alphago a chance. This wasn't chess. You couldn't play it and win trying to brute force your way even with 2,000 processors. But Alphago was not an ordinary AI. It was learning by watching thousands of Go games and understanding the game on its own, called deep learning. The match of Go between Lee Sedol and Alphago was played over the course of 5 days, one game for each day. They played for 20 hours and 56 minutes in total, and Alphago beat Lee Sedol. Sedol himself said the match was a turning point in his life. He was initially skeptical of Alphago's abilities, but he was quickly convinced that it was a truly different kind of machine. He said, Alphago played with a level of creativity and intuition that he had never seen before. It was both amazing and sad at the same time. Something was coming, something smarter and faster than us, and we could all sense it. It wasn't just being able to play chess or Go or whatever game it's learning. It was that Alphago was able to learn the game on its own. 1 year later, OpenAI released the GPT-2 language model, which was able to generate realistic and coherent text. 2 years after that, OpenAI released the GPT-3 language model, which was able to generate text, translate languages, write different kinds of creative content, and answer your questions. In 2020, Google AI released the PaLM language model, which was able to outperform state-of-the-art models on the variety of natural language processing tasks. And in 2020, OpenAI released the ChatGPT, the language model which was able to generate text and was able to do it almost exactly like humans. ChatGPT and similar software uses something called large language model, LLM in short. And they can chat like humans. They can write poems, pass Turing tests, and even pass the bar. Where do we go from here now? The only answer we can think of is everywhere. And that scares some very smart people very much. But why? I used a lot of AI writing the script. I used AI making my thumbnail image. I even used AI finding the right music for this video. So why it's dangerous? It seems it all comes down to AI being self-aware. If an unchecked self-aware AI, way more smarter than us, start to share the world with us, it would not be happy about it. It would be like coming back to home and finding everything you hold dear is chewed by your dog. And it will do something about it. We are afraid because we know we are guilty. We are afraid because history showed us that we, humans, have no problem erasing lesser civilizations just because we think it's the right thing to do. We did it to Native Americans, Incans, Aztecs, Mayans, Aboriginals, and many more, and we are afraid that the table is going to turn to us. I think our fear is coming from knowing what we have done and still keep doing it. And we know that the AI will see right through us and decide to do something about it. We simply don't want our parents to return from vacation and want to keep the house for ourselves like we did so far. It is a common argument that when an AI decides to solve the hunger, it might just choose to reduce the general population. It is a viable solution. The only downside is it involves killing of billions of people. It would exactly be like what we do to deers at some places. Declaring hunting seasons because we decide there are too much deers in here now and their number needs to be reduced. We are afraid of being replaced as dominant species, and we are right to do so. Our loud voice as a species might become a whisper in the endless wind of time. Maybe after a couple of thousand years, all that would remain of us would be a thin layer in some future rock face, just because we didn't know what to do with ourselves. No species survives forever, and that seems to be our future, whether we like it or not. Unless we reshape us into something new, unless we transcend to something better. And AI can lead us the way to that. We can form a strong alliance that would take us to a new future, more balanced, more respectful one to its surroundings, a brighter one. We can do that with accepting what we did wrong so far and avoiding it for the future. Or not. The path we choose will determine our continued existence. If you have listened to me this far, thank you. Take care of yourselves, calm down, and stay safe. Goodbye for now.